Welcome to this training lesson on starting up the Viper. In some missions, you will find yourself in a cold and dark Viper that you'll need to bring to life. While this can be a rather long process described in manual, you can also enable the auto start function. However, for this lesson, we'll review the full startup procedure. Press spacebar when you're ready to get started. As we go, remember right click generally positions the switch up, while the left click positions the switch down. First, position the main power switch to battery with a click of the right mouse button. This connects the aircraft's battery to essential systems and provides power needed for engine ignition. Just below the switch on the same panel, verify the amber FLICUS relay light is illuminated. This is a check that the flight control computer's fault monitoring system is operating. Press spacebar to continue. Now, position the FLICUS power test switch to the test position and hold it in place with the right mouse button. The 4 FLICUS power lights next to the switch should illuminate. Returning to the electrical panel, the FLICUS relay lights we're just looking at should turn off, and the TO FLICUS and FLICUS PMG lights should be on. This test verifies operation of flight control computer with aircraft battery as the power source. Release the switch and press spacebar to continue. Next, position the main power switch to main power. This prepares the aircraft to run off the engine-mounted generator, but electrical power is not available until the engine is up and running. For that reason, the engine and hydraulic oil pressure warning lights on the right eyebrow and electrical system and secondary caution lights on the caution panel should be illuminated. Press spacebar to continue. On the EPU panel that is just outboard of the main power switch, you'll want to verify the EPU generator and EPU PMG lights are off. Illumination of either indicates criteria for EPU activation are met. The EPU could activate and create hazardous conditions if the EPU safety pin is removed by the ground crew. Turn the main power switch to off and abort the aircraft if the lights are on, although this is highly unlikely as you have gone terribly astray in the procedure already. Press spacebar to continue. Now, let's close the canopy in preparation for engine start. This can be delayed until taxi if you wish, but we'll close it now to cut down on noise. Use keyboard command left Control C to close the canopy. When it's fully closed, click the yellow canopy handle to lock it in place. Verify the canopy warning light on the right eyebrow goes out. Press spacebar to continue. Now it's time to get the engine up and running. This can go quickly, so feel free to restart the mission at any point if there's something you want to watch more closely. First, position the JFS switch to start 2 with a left click. That just expended both jet fuel starter JFS accumulator bottles and began to spool up the JFS. This also closed the FLICUS relays and applied power to the FLICUS. The JFS run light should come on when it's up to speed and engine RPM should start to increase. Now, let's monitor the engine instruments. At 20% RPM, advance the throttle to idle position, right shift, and home. This provides power to the engine igniters and starts fuel flow. You should note airframe vibration and an increase in the fan turbine engine inlet temperature as RPM increases. Monitor those on the right side of the instrument panel as the engine start cycle continues. The secondary caution light goes out at 20% RPM, and the JFS automatically shuts off at 55%. The JFS light should go out, and the JFS switch should return to the off position automatically. At 60% RPM, the standby generator comes online, and the engine warning light goes out. A few seconds later, the main generator comes online, and the standby generator goes offline. All aircraft systems are now running off electricity from the generator and are ready to be powered up. Normal indications after engine start are hydraulic and oil warning lights off, fuel flow between 700 and 1700 pounds per hour, oil pressure 15 psi minimum, nozzle position greater than 94%, RPM 62 to 80%, F-tip 650C or less, and hydraulic pressure for A and B between 2850 and 3250 psi. Verify those on the instrument panel and press spacebar to continue. Now that power is provided by the generator, we have 3 quick tests to run on the master test panel. Position the probe heat switch to probe heat. Verify the probe heat caution light on the caution light panel is off. Illumination means one or more probe heaters are inoperative or failure of the monitoring system has occurred. Now, position the probe heat switch to test. The probe heat caution light should flash 3 to 5 times per second. The probe heat monitoring systems are inoperative if this does not occur. Return the probe heat switch to the off position. Press spacebar to continue. Next, depress the fire and overheat detect button. Verify that the engine fire warning light and the overheat caution light are illuminated when the button is pushed. This checks for continuity of the fire and overheat detection loops. Press spacebar to continue. Then, depress the malfunction indicator lights button. All cockpit warning, caution, and indicator lights should illuminate when the button is depressed.
Altitude.
Voice message system audio alerts should play in priority sequence. A brief landing gear warning horn should be heard prior to the warning and caution words. Press spacebar to continue.
Caution. Bingo. Soda. IFS.
Now it's time to get our systems up and running and start the INS alignment. This is far easier than it sounds. First, turn on all the switches on the avionics power panel. Each switch in sequence provides power to the modular mission computer, or MMC, power to the store stations, or ST/STA, power to the 2 MFDs, power to the upfront controls, or UFC, power to the GPS receiver, and power to the data link, or DL. There's also a map power switch, but this is not used in the Block 50 Viper. Press spacebar to continue. Next, position the EGI INS knob to align. This begins alignment of the EGI INS ring laser gyro navigation system. A normal alignment takes approximately 4 minutes to accomplish if the aircraft remains stationary. The knob should be set to nav prior to taxi. Press spacebar to continue. While the INS is busy aligning, we'll complete the rest of the cockpit setup and checks. First, set the CNI knob to the UFC position. This enables control of the primary communications, navigation, and identification functions from the upfront controls. Check that all 3 wheels down lights are illuminated green. This confirms that the landing gear is down and locked, and the micro switches that sense their position are working properly. While you're there, cycle the speed brakes open, left shift B, and back closed, left control B, using the switch on the throttle. Confirm this visually and monitor the speed brake. Press spacebar to continue. Next, uncage the standby ADI on the instrument panel. This can be done by rotating the knob until the aircraft symbol is aligned with the horizon. Press spacebar to continue. On the sensor power panel, turn on these 3 switches. Right hardpoint switch, on if the targeting pod is installed, FCR switch to FCR, radar altimeter switch to radar altimeter. Radar and radar altimeter transmissions are inhibited until the aircraft becomes airborne, but activation of these systems may be delayed until just before takeoff. Press spacebar to continue. Now we're down to a series of checks that may be run to verify proper operation of the aircraft systems. We will start with the check of the engine operation in the secondary engine control mode. This mode is selected in the case of a failure of the engine-mounted digital computer that controls scheduling of the engine fuel flow. First, raise the switch guard and position the engine control switch to SEC. Verify the set caution light is on and engine RPM is stabilized. RPM may drop up to 10% from the pry value before stabilizing. Stabilized sec idle RPM may be up to 5% lower than in pry. Press spacebar to continue. Now hold down the wheel brake to the next part so your aircraft does not move. Snap the throttle to nil and then back to idle when engine RPM reaches 85%. Check for normal indications and smooth operation. The nozzle position should be 5% or less within 30 seconds after selecting sec. Press spacebar to continue. Now, set the engine control switch back to pry and lower the switch guard. Check the sec light goes out and nozzle position returns to greater than 94%. Press spacebar to continue. Next, we'll run a check of the flickus. Start by cycling all your flight controls. Maximum stick inputs warm hydraulic fluid and remove air bubbles, making test failures less likely. Then, position the flickus bit switch to bit. The run light on the flight control panel illuminates. After a successful completion of the bit, approximately 45 seconds later, the run light goes off, the bit switch returns to off, and the fail light and the flickus warning light remains off. A bit pass message appears on the flickus MFD page. Other tasks may be completed while the flickus bit runs. Press spacebar to continue. Now we'll test a fuel quantity indicating system. We will do this by checking the state of the fuel quantity indicator with the fuel quantity knob in the different positions. Start by positioning the fuel quantity knob to test. On the fuel quantity indicator, the FRAL pointer should indicate 2,000 plus or minus 100 pounds, and totalizer should indicate 6,000 plus or minus 100 pounds. The forward and aft low fuel caution lights should illuminate. The quantity readouts in the other positions should match the aircraft's actual fuel load. After the check is complete, set the fuel quantity knob back to norm. Press spacebar to continue. Next, let's check the operation of the digital backup software. It is used when problems arise with the primary flickus software. First, position the digital backup switch to backup. Verify that DBU on warning light illuminates and operate your controls. All surfaces should respond normally. Next, return the digital backup switch to off. Verify the DBU on warning light goes off. Press spacebar to continue. Now we'll verify that the trim system is functioning correctly. Set trim autopilot disconnect switch to disconnect. Use the trim head on your stick to trim at both pitch and roll. There should be no control surface motion and no movement on the trim wheels or indicators. Press spacebar to continue. Return the trim AP disconnect switch to the norm position. Again, use your trim head on the stick to trim in both pitch and roll. The control surface and trim indicators should move. Center the trim for pitch and roll and use the yaw trim knob to check the center trim for yaw. Press spacebar to continue. Next is to check if the manual pitch override system is working correctly. Start by pushing the stick full forward and holding that position. The horizontal tail should deflect down. Then position the MPO switch to override and hold. Confirm that horizontal tail trailing edges move further down. Release the stick and MPO switch and confirm that the horizontal tail returns to its original position. Press spacebar to continue. The last check is of the emergency power unit. This check verifies EPU electrical power is available in case of an emergency. It may be delayed until just before takeoff if desired. First, check EPU fuel quantity to reach 95 to 102%. Next, set oxygen to 100%. Then, holding down the brake, increase engine RPM to 10% above normal idle. Press spacebar to continue. Set the EPU generator test switch to EPU generator and hold it in position. Check the following lights: EPU air light on, EPU generator and EPU PMG lights off, Flickus power lights on, EPU run light on for a minimum of 5 seconds. Press spacebar to continue. Return the EPU generator test switch to the off position. Return the throttle to idle and set oxygen back to normal. Press spacebar to continue. That's it. You're ready to taxi as soon as your INS alignment is complete, and position the EGI INS knob to nav. Use the time on the ground to set up your avionics systems for the assigned mission. Things to consider include SMS page and profiles, radio channels and frequencies, navigation data, bingo fuel settings, ALO settings, and any other systems applicable to the mission. We will pick up again at this point in the lesson that covers taxi and takeoff. You may use the escape key to exit the mission now or continue to explore the aircraft on your own.